Hey folks, Mr. Hempstead here, back with another good one on density. Today we're going to be learning a little bit about specifically the density of liquids. Okay. Over on the left in red is our target. Our target is to be able to predict how the density of an object affects whether it will float or sink. And we're primarily going to be looking at liquid objects. So, sometimes when you mix liquids together, they're not going to mix. And if they have different densities, they're going to form layers, kind of like the diagram that you see over on the right. The liquid with the lowest density is always going to be on the top, and the liquid with the highest density is always going to be on the bottom. So what I thought we could do is actually do a little bit of an experiment where we're exploring these densities and just kind of figuring out how they work. So I've got some corn syrup right here. And right now, the only thing on top of it is gas. Okay, so there's some gas on top of this corn syrup. Does that mean that gas has a higher or lower density than corn syrup? Good. Remember, if something floats on top of something, it has a lower density. So the gas that floats on top of the corn syrup right now has a lower density than the corn syrup itself. What if I took something like this little metal marble ball and I put that in the corn syrup? What do you think is going to happen? Go ahead and predict what you think will happen to the marble ball when it goes in. Here we go, let's find out. So it happens fairly slowly because the corn syrup is very viscous, but gradually the marble is starting to sink lower and lower into the corn syrup. Because the marble is sinking into the corn syrup, does that mean it has a higher or lower density than the corn syrup itself? Because the marble sinks, it has a higher density than the corn syrup. Cool. All right. Over here, I've just got a lot of water. I've added a little bit of blue food coloring to it. And what I'm going to do is I'm going to pour this water and the blue food coloring into my beaker with the marble and the corn syrup. So this water has a density that is lower than the corn syrup. Because the density of the water and blue food coloring is lower than the corn syrups, what would you expect to happen? Will it float? Will it sink? Is it gonna mix together? I'll give you a hint. It's not gonna mix together. So, is the water gonna float or sink? Here we go. So we can see that the water is floating on top of the corn syrup because its density is lower. Let's try another one. So I've got some vegetable oil, and I'm gonna pour this vegetable oil into my beaker. Vegetable oil's density is about 0.4, all right? And water has a density of 1. So knowing that water has a density of 1 gram per milliliter and vegetable oil has a density of about 0.4 grams per milliliter, what would you expect to happen? Let's find out. Gotta be careful. Here we go. Ooh. So when we put our vegetable oil into the water, it goes on top. And this is because its density is lower than water's. Next one. Got some acetone. So acetone, it has a density that is still lower than that of the vegetable oil. So what do you think is going to happen? Is it going to float on top of the vegetable oil? Is it going to float on top of the water but sink in between the vegetable oil? Remember, the nail polish remover, the acetone, its density is less. Here we go. Now I have to be very careful about this particular step because I don't want it to go very quickly. It's a very low viscosity solution. There we go. So we can see that as we add the acetone to the container, it's starting to float on top of the oil. Weird. So we've got all of these different liquids kind of stacked on top of each other. Let's try a couple of solids and just see what happens to these solids when we put them in the waters and oils and acetones and things like that. Let's see what happens to a couple of different other objects. So I've got just a little piece of wood. This is just like a fraction of a popsicle stick. Go ahead and predict what you think is going to happen to the popsicle stick. All right, here we go. I'll push it down a little bit. Okay. And it still floated back up to the surface. So what does this tell us about the density of the popsicle stick? Is the density of the popsicle stick higher or lower than the density of acetone? It means it's lower. Remember, lower density means something floats. This is a little piece of plastic. It's called a Knex for those interested in. We're going to see what happens with this Knex piece. Interesting. So the Knex, it sank through the oil and it sank through the acetone, but it's floating on top of the water right there. So what does that tell us about the density of the Knex piece? Good. That means that the density of the Knex piece is higher than the vegetable oil or the acetone, but it's lower than the density of the water. Pretty cool. Science. This is totally an experiment you can try at home. All of these ingredients are things that I bet most of you guys have in your house. So feel free to give it a shot. It's kind of cool. Have a good one. Bye, folks.